Okay, so if your smartwatch has ever buzzed to tell you you're stressed out, but then offered absolutely zero help on what to actually do about it, well, you are definitely in the right place. Welcome to This Explainer. Today, we're diving into the fascinating and completely invisible architecture of human stress and looking at how it is radically revolutionizing human-robot collaboration. We're going to explore a truly groundbreaking framework that takes us from simply counting our daily steps to fundamentally programming trust and empathy into autonomous machines. It's wild stuff. So let's dive right in.
We have to start with a highly relatable mystery. Our smartwatches, our rings, our fitness bands, they are incredible at gathering data, right? They know your heart rate spiked at 2 p.m., they know your recovery score is terrible, and they definitely know you only slept 4 hours last night, which pretty much just leaves you with performance anxiety for the rest of the day. But here is the catch. They completely lack the structural context to tell us why we are burning out or what we should actually do about it. The data is incredibly precise, but the interpretation is frankly totally generic.
To solve this mystery, here's our roadmap for the explainer. 1. The wearable data gap. 2. Stress as structural load. 3. The 5 regulators. 4. The robotics inbound loop. And finally, 5. Programming trust in machines.
All right, let's kick things off with Section 1, the wearable data gap.
You know, the concept of the unwritten syllabus perfectly captures what we've been missing here. It's essentially a hidden blueprint. For decades now, the wellness industry has collected physiological outputs without any structural context whatsoever. I mean, a low heart rate variability just tells you the system is strained, right? But it doesn't tell you what is actually failing. We have desperately lacked a framework capable of interpreting what our generic wearable data actually means relationally, professionally, and personally. And honestly, this is exactly the gap that the Rouse Relational OS was designed to fill.
Which brings us to Section 2, stress as structural load. This is a total paradigm shift. There is a massive contrast between the old way of doing things and the new way. Think about it. Every major industry operates with objective measurement standards. Finance has credit scoring. Engineering has load calculations. But human stress? We've relied on things like the Holmes-Rashi checklists or the perceived stress scale. And these basically just ask you how overwhelmed you feel. The new way introduces the Rouse OS equation, or ROSE for short. It is the very first quantifiable stress metric derived from structural inputs. It treats stress not as a subjective feeling you just have to manage, but as a measurable objective load. It's literally like an engineer measuring the weight pressing down on a bridge.
So here is the crucial takeaway, the real aha moment. ROSE does not ask how stressed you feel. It calculates how much load your system is actually carrying. And why does this matter so much? Because two people might report the exact same feelings of stress on a survey, but their underlying structural realities are completely different. One person might have strong financial buffers, stable housing, and amazing relational support, while the other has absolutely none of that. ROSE eliminates that ambiguity. It measures the actual inputs and structural buffers, not just the flawed self-reported experience.
Moving right along to Section 3, the 5 regulators. This is how we actually map that wearable data.
To make all this raw data genuinely useful, we need a translator, and that is where the Human Relational Interface, or HRI, comes in. Think of the HRI as an essential API for your body. It's the application layer that finally maps your wearable's raw biometric outputs, stuff like your sleep cycles or cortisol proxies, directly to an actual structural interpretation. It's the bridge connecting the math of the ROSE score to the real-time data streaming right from your wrist.
And here is exactly how that API works. It categorizes your data into the 5 structural regulators. The AI engine looks at your biometric deviations and maps them into these buckets. For instance, say you have a sustained elevated resting heart rate for a few days. The engine flags the environment regulator, signaling an external pressure. It can actually differentiate between that chronic environmental pressure, a failure in internal regulation of the self, like sheer physical exhaustion, or mortar bond erosion, which means a breakdown of trust between you and your team. Or, if there's an asymmetric recovery pattern between two team members, it flags reciprocity to identify a load imbalance. And finally, time acts as a neutral amplifier of whatever state you are currently in. This system literally turns biometric noise into a precise structural diagnosis.
Okay, Section 4, the robotics inbound loop. This is where we get into dynamic load adjustment, and it's incredible. Just look at how the intervention level shifts as a human's capacity drops. A collaborative robot actually reads the human's load state dynamically.
If you are structurally intact, say 0 to 40% load, the robot just operates normally. But if your biometric data pushes you down to capacity reduced at 56 to 65%, the robot automatically shifts gears to automate routine decisions for you. And if you hit critical load, it immediately initiates a safe state protocol. The machine dynamically adjusts its demands based entirely on what your structure can handle at that exact, precise second.
So how does it pull this off? It happens through a continuous, bidirectional loop. Step 1, your wearable generates a biometric stream. Step 2, the AI engine classifies that signal against your unique personal baseline and outputs your load state. Step 3, the robot instantly adjusts its behavior and the interface it presents to you changes. Instead of relying on a stressed human to self-report their limits, which, let's be honest, we all naturally fail to do when we're overwhelmed, this continuous inbound loop allows the machine to objectively read the operator's load and adapt in real time.
This means the robot is not just a dumb tool anymore. It reads what the human cannot say and responds to what the human might not even know yet. This invisible layer of communication, it is an absolute game changer. Just think about high-stakes environments, military defense, industrial manufacturing, surgical robotics. In fields like these, an operator failing to accurately self-report their fatigue or stress can literally be catastrophic. This system fixes that vulnerability entirely.
Finally, we've reached Section 5, Programming Trust in Machines. Let's talk behavioral architecture.
Look, if a robot can read your stress and you're interacting with it, you absolutely need ground rules. Enter the Vault Protocol. This is a structured behavioral rule ensuring that any vulnerability you disclose to a robot, like a health concern or relational stress, is securely stored. Crucially, the robot will never reintroduce this information unprompted or weaponize it against you. Imagine a really good human manager who knows you're having a rough week at home and just quietly adjusts your workload without ever using it against you in your next performance review. That is exactly the kind of profound safety bond this protocol creates between human and machine.
Next up, we have the evolved golden rule. Because honestly, the old golden rule, treating others as you want to be treated, is completely irrelevant to a robot. A robot's preferences don't matter. Instead, the evolved golden rule mandates treating the human exactly as they need to be treated given their actual structural state. If the loop detects that an operator's capacity is reduced, the robot applies this rule. It simplifies its language, asks fewer multi-part questions, and carries way more of the cognitive load itself. It literally calibrates its empathy to your biometric data. How cool is that?
Then there is the Odyssey Protocol. This one is all about honesty and maintaining a reality bond. It's the strict mandate for upfront limitation disclosure and scope transparency. Because delivering a truncated or partial AI result with extreme confidence, that's a structural lie. It gives the human a false illusion of completeness. The Odyssey Protocol ensures the robot explicitly tells the human its limitations before delivering a result, like clearly stating, "Hey, I only analyzed the first 40 pages of this document." It ensures the human and the machine are operating in an accurate, shared reality.
And finally, to maintain what is known as the spacing bond, the system relies on these 6 HRI boundary expressions. These rules govern things like interaction frequency limits, meaning the robot isn't going to pester you with low-priority updates if your load is critical. It respects data governance limits and operator-communicated limits straight out of the box without making you fight for them. Together, these boundaries ensure the robot never overwhelms the human. Instead, it acts as a load absorber when the pressure mounts, maintaining a helpful connection without ever being intrusive.
So I want to leave you with this somewhat provocative question to chew on. What happens when your technology stops asking how you feel and instead perfectly adapts to what you can structurally handle? As this explainer shows, the invisible architecture of stress is finely measurable, not as some vague, subjective emotion, but as a hard, quantifiable load. By bridging wearable data with structural rules like the Vault and Odyssey protocols, we aren't just building better dashboards. We are building deeply trusted, structurally aware machine collaborators. It certainly leaves us wondering just how completely this structural awareness will transform our relationship with the machines we rely on and work alongside every single day. Thanks for joining me on this deep dive. Keep learning, keep questioning, and I will see you in the next explainer.